Good evening and welcome to the Orkney International Science Festival 2024. My name is Catherine Young and I'm a PhD student at Glasgow University, a STEM ambassador and a volunteer here at the Science Festival. It's my pleasure to be hosting this session again, the Orkney Sky at Night. Join us for an hour's talk to hear about some of the superb objects in the night sky that can be seen by enthusiastic amateur astronomers. There'll be pictures, star maps, and the opportunity to ask questions about stars, planets, aurora hunting, and using binoculars and telescopes. I want to encourage you to all take part in this event and ask you to enter your comments and questions in the YouTube chat, and I will present them to Eric and Callum during and after the talk as well. So to our speakers, today we are joined by Eric Walker and Callum Potter. Hello to you both. Can you tell me a little bit about yourselves and your connection to astronomy and observing the night sky? I'll start with Eric.
Oh, right. Well, hello, I'm Eric, and I was the past chair of Highlands Astronomical Society. I got interested in astronomy. Well, I actually got interested in astronomy when I was in my early teens. And then there was other interesting things to do, but I got back into astronomy at a much later age, and in 2004, my wife bought me a telescope. I'd asked for a backpack telescope. I got this great big box on my birthday morning, and in it was an astronomical telescope, and she was horrified, but I was delighted because it resurrected a passion in me that I had forgotten I had, and I got really hooked into it. I now do observing astronomy, I do astrophotography. I help coach people. I'm still in the committee of the Highlands Astronomical Society, but I'm really very active at doing astronomy.
Brilliant. And Callum, what about yourself?
Well, I got started in astronomy during space age, really, I suppose. The moon landings were sort of inspirational to me, and again, similarly to Eric, I was pretty active in an active interest in astronomy until work got in the way, really, and then children got in the way. And then once children got old enough, then I started being a bit more active again. I've been with the British Astronomical Association since 1996, I think it was, when I joined the first time. And it's a great organisation, actually. We've got about 2,600 members around the UK and the rest of the world. We've got lots in USA and Europe and Far East as well.
Can anyone join?
Anyone can join, yes. Only if you pay your money, we're very happy for you to join the association. One of the great strengths of the association is we've got the number of observing sections, which all have an experienced observer sort of at their as a key person, the section directors, as they're called. And we cover everything that there is possible to see in the night sky. So if you've got any interest, any niche interest in astronomy, then there'll be somebody that's an expert there to help you along. Yeah. My remit is the deep sky, so I'm the deep sky section director, since I put a galaxy in the middle just to illustrate that. We also have this journal which comes out every 2 months, which has some technical papers, but also a lot of useful introductory material and just information on what's going on in the sky each month.
Yeah. I can actually vouch for that because I'm a member of the deep sky one, also the solar one, and the lunar one.
Yeah.
And I think they also offer up a challenge usually that we try and get a photograph of something. But it is a challenge actually trying to find some of these objects. But it makes it fun actually. So,
yeah, that's right. Yeah. So all the sections directors will generally communicate with their members regularly, and it's very good to participate in those sorts of things and try and encourage people to observe, really, because the association's an association of observers. It's not meant to be highly technically scientific.
Oh, Callum, you mentioned a space age just there, and that's what maybe got you into astronomy. What about yourself, Eric?
Well, as we're obviously
similar ages.
Yes, I do. I actually remember. I watched all the Apollo missions. I mean, they were really heavily publicised, especially after President Kennedy made his famous speech about we don't do it because it's easy, we do it because it's hard, sort of thing. And There are people I remember James Burke and Raymond Baxter and Cliff Mitchellmore and people like that.
Well, Eugene Schumacher,
Oh my goodness,
who's
yes.
the famous geologist
Yes.
who thought that craters, the meteor craters on Earth were actually caused by meteors and so other caused by other events, and he was proved right. And he went on to observe comets and be an expert on lunar geology as well. So yeah, there was a lot of people who have had a long history of promoting science and they were associated.
It was a good time. This is all you're talking about. The late '60s, really, where it really peaked. And Patrick Moore. How can I not mention Patrick Moore, who led the BBC Sky at Night, which was a wonderful program for ordinary people to understand elementary astronomy and do it.
And this place that we're looking at here is the Mills Observatory in Dundee, and I just wanted to give it a bit of a shout out really on the programme tonight. Houses this lovely refracting telescope as a Cooke refractor, a fairly historic instrument. And when I was at school, it's a long time ago, we used to go on school trips to the Mills Observatory from Kirkcaldy and look through this very telescope and had first views of Mars and Saturn. And it was run by a very interesting guy called Harry Ford. And he was a really another inspirational character of in astronomy. Unfortunately, the Dundee City Council have had a review of whether they want to continue funding the Mills Observatory, and they've recently had a consultation. There's been a big petition to keep it going, and there seems to be at least a short-term future for it, if not a long-term one. And there's been some industrial partners come forward to sponsor its ongoing life. But it is a key resource for encouraging STEM and bringing in children to see the stars and to encourage an interest in astronomy.
One of his trivial pursuit facts, it's a paper mache dome.
That's right.
Paper mache dome, yeah. And the reason I know that is because the first observatory I built for myself in my own back garden, I built a geodesic dome out of plywood, but I covered it with paper mache and then bolt varnish to waterproof it. So
that's brilliant, and on such a large scale as well. Yeah, brilliant. Well, shall we have a wee look then now at the autumn night sky? What kind of things can we expect to see coming up?
So this is a view of the sky looking southwards, and this is just showing the stars that are on the sky. So it was really quite difficult to pick out the constellations and things just from using a map like this. This is using software called Stellarium, which is a completely free piece of software, and you can get it to run on Windows, on Macs, and any other sort of PC you might have at home. And if we go on the next slide, then we can switch on I've got my slide order mixed up. So there's three bright stars that we can see in the sky at the moment: Deneb, Vega, and Altair, and they make up a triangle of stars that you would call the summer triangle. So it's heading towards the west now. Now that we've been past the height of summer, and these are our three main marker stars when we're finding our way around the night sky. We've got the Milky Way running from the horizon up to the top of the screen there, and that goes through Altair and Deneb.
Yeah, these stars are actually distinctly bright. You can't help but notice them. And that's why us amateur astronomers use this very often to bear off it to find certain objects. And that's what you're going to be doing with this one.
That's right. Yeah. So I think on the next slide we've actually got the useful stick figures that star maps tend to produce, and if you're looking at the top of the map there, we've got the constellation Cygnus, which is like a big cross, but it's meant to be really the Cygnus the Swan. So at the top of the the cross is the head of the swan, and the tail goes down towards the bottom, and the two arms are the wings of the swan. And at the very top of that cross is that star deneb, and it's very obvious to find and easy to see. If you go down to the tail, there's a lovely pair of stars there, a double star called Alberio, and that's a lovely star for the telescope. It's actually two stars, a yellow and a blue one. That's a fantastic little star to go and view.
It's one that when we take people to the observatory at our club, it's one that we always show people, especially at this time of year, for the next few months. It's so distinct. Yeah.
And all of these things that are on show here will be around for the next couple of months before they start disappearing into December. Towards the end of the year, they will be quite so visible as they are.
Why is that? Is autumn a better month for?
Well, there's different, because of the way the Earth rotates around the Sun. Different constellations come into view at different times of the year. So if we look due north, then you'll see the stars which you see a set of constellations which you always see from your location, because they just rotate around the North Pole. But the other ones, as the Earth rotates around the Sun, we start seeing constellations in the winter that we don't see in the summer. So constellations like Orion, the Hunter, is a winter constellation. You wouldn't see it until starts picking up over the horizon, just now really.
The ancients probably used it as a calendar marker to when they start to see the top stars of the constellation coming up. They probably use them to say we'll better get our beasts down from the high ground down low, because the winter's just a month or so away. So,
Brilliant.
But we've got some nice planets on view at the moment. So if we go on to the next slide, you should be able to see the first of the. If we go to the back, go back one minute. Yeah. So we've got the bright planet Saturn visible, and it's fairly low there in at the moment. But and it's still going to stay fairly low through the rest of the season, unfortunately.
Where are we located with this map?
We are actually located in Orkney.
Right, so we're very north.
So this is actually designed for my home observatory in Rousay. So we have a very restricted southern horizon. If you go further south, or if you live further south,
well, I'm about 80 miles due, so I'm about a degree of latitude south. But if you were down Edinburgh and
That's it in Glasgow.
Yeah,
well, you'd see it a lot higher in the sky in Glasgow, and you'd see that low horizon. You would see more stars below that. So we have got a fairly restricted southern aspect in Orkney.
Yeah. So it's an advantage at the moment to be a bit further south to observe.
That's great.
And the real enthusiasts will go to far south locations to view some of these objects. They'll go to.
Is that the Dark Skies Park at the Borders? Is there one there?
Probably.
That observatory is not there anymore.
I see.
It had an accident and brought it down.
Oh.
Unfortunately, they're talking about re-establishing it, but at the moment there's no observatory there anymore. But it is a good place to go. You can still go into the forest and observe from there. And that is a very dark spot. But people go to France or people go to the Caribbean just to do observing at certain times for certain planets.
But for the planets, for casual observing,
which we are encouraging here.
It makes no difference. No. So I thought we've got Saturn here. If we go on to the next slide, then we've got a couple of pictures of Saturn coming up. And that top left picture is a recent picture of Saturn taken by BA member James Dawson. And that shows Saturn what it looks like roughly now. I mean, this was a few days ago, but it's pretty much like this. But you'll notice that Saturn's rings, these are these very small rocky bodies which go around the satellite, around the planet. A destructed satellite, we think. And they're formed this thin ring, only a few miles thick. But at the moment, because of our sort of geometrical aspect between us and Saturn, we see the rings when they're what's called edge on, so they just look like a very thin sliver of light going across the planet.
But it's actually useful if you can see you can actually see the cloud bands a lot easier because there's less reflection.
That's right.
Of the rings. If you look at the one 2 years ago, which is much more at an angle, I mean that's a very good astro photograph, but with a telescope you'd have a job seeing the cloud bands.
Yeah.
How were these photos taken?
These are usually taken with like something like a webcam or a video camera, which takes on a telescope, and it takes lots and lots and lots of images.
You're talking about hundreds or thousands of images
as a video file, and then there's processing software which will select out the best ones, throw away the rubbish ones, and then they use what's called a process called stacking. So they add all the pictures together in software, and then that produces a final image. And then there's usually, once it's been stacked, there's still then a process usually of image enhancement to accentuate the details and to improve the contrast and visibility.
You wouldn't see it like that through a telescope.
Yeah.
You would probably more like.
I chose the first.
Would you be able to see the ring?
Oh yeah,
Absolutely.
No, I chose the first one because I think that gives a reasonably good view of how you might see it through a small telescope.
Small mid-sized telescope.
We'd look Saturn a bit like that at the moment. And there's no real detail to be seen on the rings. When the rings are inclined, with a good telescope, you can see gaps in the rings and these sorts of
I have to say, when I saw Saturn for the first time, I think it was like 2004. I remember it was a real wow factor. If you weren't into astronomy, that got you hooked. To be honest, Callum.
I agree. I think
it
was one of the things I saw at the Mills Observatory, and that stuck with me to this day. Yeah.
Would you be able to try and take a photo from your own backyard then?
Oh yeah.
Then how would you set that up exactly? Would you have a telescope and try and put your camera onto it?
That's like that, is it?
Bit of duct tape even.
You wouldn't even need that. You wouldn't need that. You could get your telescope on it, and because the planets are so bright, you just put your smartphone camera lens onto the eyepiece, and it takes a bit of the one thing I would say.
A bit of adjusting.
You just to get it aligned, and once you get it aligned, push the button, and you've got these ones that do the bursts. They're quite good. That's a good way of taking a few pictures, and you'll get more than a decent picture. And the processing software that's on smartphones now is actually good enough that you can do a bit of enhancement on your phone. Without over enhancing it. It's amazing, and that's another thing we try and encourage people to do. Yeah.
Brilliant.
I think it's important that people just have a go. And try things like using smartphones. I mean, I remember a long time ago I was doing a solar observing session with my solar telescope, and I've always struggled with using a smartphone with the solar telescope to get nice pictures of the sun. And one of the folk that just came along to see the sun took their phone, put it over the eyepiece, took the picture, and it was a brilliant picture. It was far better than anything.
We probably overthink it.
Exactly.
Was this at the Science Festival last year?
No, this was a few years ago at an event in Cheltenham. But it was it can be quite frustrating sometimes. But it's just give it a go. Really.
How about other planets? Is there another opportunity to see other planets?
Well, we've got 2 other planets coming up in the sky at the moment. You have to wait a little bit longer in the night. So in the east, rising at the moment, we've got the planet Jupiter.
That's a fantastic
planet. It's a super planet to see. And if we wait a little longer into the night, we'll look at the next slide. We'll also get Mars will start appearing in the eastern sky.
Yeah, Jupiter there it's just above the centre there. That's where Jupiter is. Almost due east. That'll be about 3 in the morning, I would think.
This is very early. They will be higher in the sky earlier as we head in towards winter.
So as you go October, November, December, that'll come back. That'll be observable pretty much like that.
And
or
the nights get
10, 11 o'clock,
get darker earlier,
yeah,
so
yeah.
these things all become a bit more
Yeah.
available for easy viewing.
Yeah.
So
Jupiter's easy. It is so bright that you literally cannot miss it. It's so
yes, and it is a distinctly orangey red colour.
Yeah.
Mars is also not so bright at the moment.
Yeah.
But again, it's got this distinctly reddish hue, which is
Yeah.
a little bit different to some stars.
Mars on that screen there. Mars is if you've got Jupiter, if you go slightly to the bottom left, you'll see the classic red orange colour of Mars, and that's distinct. You when you look at it with your eye in the night sky,
Yeah,
it's distinctly orangey red, isn't it?
That's right. Yeah. And I think we've got a couple of pictures of Jupiter and Mars coming up. So these are from the British Astronomical Association members. This is actually from the Jupiter section who analyse images of Jupiter and to see what's happening on the various cloud belts. And this is fairly recent images, I think, of Jupiter. So these are, if you like, sort of the state of the amateur art of imaging of Jupiter.
I have an observatory in my back garden. I've got an 11-inch scope with the proper, good quality cameras. And I know how to do this, and I can get pretty good images. I just can't quite get the sky seeing conditions.
Yeah.
There's always a bit of hazy, wobbly cloud, and you can process out a bit. But these ones I'm looking at here, Callum, they are.
I mean, some of these are from people in like equatorial regions, so or Australia as well. So they obviously have better aspects of Jupiter at the moment.
They're not from the Scottish Highlands on a...
They're certainly not from north of Scotland. But they show well the bands, and those are, you can see the bands with a medium-sized telescope or even a small telescope on a good night, with a little bit of magnification. And there's also this object on the surface of Jupiter, which you can see in the bottom, third one along from the bottom. This is called the Great Red Spot, which is a spot which has resided on Jupiter since really we've been able to observe it. Huge storm, swirling vortex of clouds and gas, and why that's lasted like that for such a long time that's a real mystery.
I remember again when I was first observing it properly through a small medium telescope, and what I noticed about Jupiter was it wasn't actually spherical. It was slightly flattened.
Interesting.
Flattened. It's not egg-shaped that, but it's because Jupiter's a massive gas planet. It's the biggest planet in our solar system, and it spins very fast. It's only 10 hours to do an orbit. Like we take 24 hours. Right?
Yeah,
it takes 10, and it's massive. And because of that, it's thrown its mass out in the middle, so it looks slightly squidged, flatter than it is. Yeah, it's good.
We have 2 astronomers right now at the Cathedral of the Quilt, and a lot of the squares within that quilt are based on Jupiter. I think it's a firm favourite in the society, and a lot of kids are engaging in it as well, and they really love to talk about the storm. And they actually have learned a lot from the Science Festival in previous years too, engaging in it, so it's great to hear that.
Well, the simple telescope, there's the small ones, like the astronomy club has. You can easily see these cloud bands. There's another picture I'm seeing there, starts from the top. Can you see a little black spot?
Yes.
Now that's not a bit of dust on the photograph. That's the shadow of one of Jupiter's Galilean moons. The sun is shining. You can actually probably just see the moon slightly to the left of it. There's a little spot. I'm pointing. And that's it. Well done. And the sun's shining and it's casting its shadow on the cloud surface. Now again, even through a small telescope, you can see that. It looks like a full stop on a piece of printed page. It's very distinct. And see when you see that, it's wonderful. You can use you get phone apps, you get astronomy apps on your smartphone.
I have one actually now.
Well, you can scroll through. You can watch the orbit of the spinning of Jupiter over days, weeks, and you can see when there's going to be what's called a transit of a moon or a shadow. And then if you're lucky enough, take your scope out at that time, and you'll
good weather conditions too.
And for 4 hours or so, you'll see that you'll see that shadow, what looks like crossing its face.
Yeah.
So yeah, you can, an amateur astronomer person can see that, no problem.
Wow, brilliant.
But you can also see the moons of Jupiter with a very small telescope.
Yeah.
Even binoculars.
Binoculars will show them. There's 4 bright Galilean
Four
moons.
bright Galilean moons are, and if you watch them doing their little dance around the planets as they orbit.
It does. It looks like they're actually, you're moving. You look like in an hour or 2 or 4 or 5 hours, and they've moved positions. And it was actually Galileo that
discovered them.
And he worked out that they were orbiting the planet. Now that was heresy, literally heresy at the time, which he got tried for.
Exactly.
Because things weren't supposed to revolve around anything else. And he worked it out, and he has worked through other people's theories, and from there on, he moved on, leaps and bounds. So
yeah, absolutely. Shall we move on to Mars?
Yes, and if we go on to Mars, so this is again, Mars is rather small, and I've always found it difficult to see Mars very well. Perhaps because my aspect's not very big. It's not very good. So and you need to use lots of magnification to see much of the surface detail of Mars. And recently, of course, it's again still fairly small. I think this what's called apparition of Mars is the period where it's observable from the Earth.
I'm trying to remember how many years ago, Callum, it was 5 or 6 years. It's probably longer than I remember. But Mars was quite close to us.
Yeah. And
I was able to get images like that.
Yeah.
As good as that. But it is small now. It's hard to see the surface detail.
But if you've got a telescope and you've got reasonable magnification, it's not a problem of the brightness, really. It's a problem of the atmosphere and the atmospheric conditions. Yeah,
we're looking through too much. We look through a lot of moisture, and it's a bit like looking at a brick in the bottom of a swimming pool sometimes, isn't it? It's wobbly. It's the best way I can describe it, yeah.
And if you take images, you can obviously throw away the ones that aren't very good. Here we're just moving on to what we can see in the North Sky now. And we've got the standard northern constellations, which I'm sure a lot of people will recognise. And the Ursa Major, the Great Bear, is in the middle of the screen there, with the pointer stars pointing up to the pole star. So the 2 stars at the right of the bowl of the Plough or Big Dipper point their way up to the pole star. Yeah,
the pole star on that diagram is literally in the middle, about 3 centimeters down on my screen. I don't know if you can see it.
Oh yeah. And the pole star, I just been at a performance and talk tonight called Ursa Minor, which is inspired by the Little Bear as the constellation. Who again, it's a bear. It's a small bear. And its tail is the end of its tail marks Polaris, and the rest of the bear coming away from them. And Polaris, the Ursa Minor rotates around appears to rotate around Polaris. Of course, it's the Earth that's rotating, not the constellation itself.
Actually, just looking at these star maps, Callum, it's reminding me. See, when people are wanting to take up this hobby, this pastime of watching the night sky, it's actually worth spending some time to learn the basic constellations, or the basic asterisms, as we call them, the shapes in the sky, like the summer triangle and things. It helps you just know where you are in the night sky, and you can bear off all these things to find some of the more tricky but very, very interesting, fascinating things to look at.
Would you say that apps are a good way to start with getting your bearings on this?
Yeah, it depends. It's all to do with your learning style.
Yeah.
Apps are good.
Practicality, though, you want somebody to show you.
You know what? I think you would. And again, that's where if you know someone, a friend of yours that's into it, great. But again, I would always recommend, everywhere has got a local astronomy club or group. Seek them out and get in touch, because all the clubs that I know that are in the north of Scotland, certainly, the members are ordinary people, and they love to teach and coach other people of all ages. And that, yes, someone can take you through it.
Yeah.
That's definitely the best way.
How about planetariums? Do they serve a good purpose as well for things like that?
I don't know. For learning to navigate yourself, I don't think so.
It's more of a
But they give you a feel for. So instead of us looking at this flat screen sky map we're looking at now, you get a feel of what it's probably more like outside.
Yeah.
But there's very few planetariums that ordinary amateur club observers. So but they're good to go to because often they have a show of something specific that they're trying to show you. So they're very useful for teaching you about things. But navigating the sky live, I'm not so sure.
Are there any new things to witness in the sky as of this year?
Right, yes. Something really, well, no, I was going to say really exciting, but it's probably only really exciting to astronomy geeks like us. But I was going to introduce this topic as exploding stars, and we've got two main types of exploding stars, which aren't really exploding stars, but we flashed a bit.
You're talking about supernova.
So there's supernovae, which are stars which do actually explode, and then we have novae, which are brightenings of stars, and one particular type of novae is a recurrent nova, and that happens periodically. And there's one star called T Corona Borealis, T called Bor for short, and it's a double star. So all of these novae are double stars, and we've got a small but very hot and quite massive actually white dwarf star, which is the one on the left on the screen here, and on the right a red giant star. And they're so close together that this white dwarf star is pulling material from the red giant star towards itself. And there'll come a point where it's gathered so much material that it will just have a big flash of as that material gets instantly burned up, really.
Is it destroying itself, or is it just?
It's not destroying itself. That material that's being transferred comes into a disk around the white dwarf, and then it's just that disk of material will, if you like, not ignite is probably not the right word, but it's probably what you might think of it. And this particular nova last happened in 1946. And it happens something like every 80 years, but it has been getting quicker. So we think current predictions are that it might go off in either the autumn this year, September, October, November, December, or it might be another 2 years. It's one of these sort of unknown things.
It's a once in a lifetime event that's reasonably predictable, not necessarily accurately predictable.
Yeah. So it's not like Halley's Comet, which we know exactly when it's going to come back to visit the inner solar system. We can predict that with absolute certainty.
Read something about this. I think there's like the NASA.
There's various alerts that you can send up.
How far in advance do you think we would know?
We won't know in advance at all, probably.
Really?
Until it actually goes off. And one of the problems of it is that it's very short-lived.
Right. Okay.
So when it's going to be really bright, and it's not going to be hugely bright, not like what you might expect a supernova.
I was going to ask, is it going to be daytime bright?
It won't be daytime bright.
Right.
It will, to use a technical term for astronomy, it will be about first magnitude.
Well, that's bright,
which is quite a bright star. It will probably be brighter than the other stars in the constellation it's in. But it will probably only be that bright for maybe one day.
Yeah.
So it's a good chance that it will go, it might go off in our daytime. But you'll be able to see it with binoculars or a small telescope for a while.
Well, if that's in Aurora Borealis, I mean, that's visible to us, isn't it?
It's visible to us right now, yeah. So if we go on to the next slide, we can see where it sits. So this constellation, Aurora Borealis, is an interesting little constellation. It's a little circlet of stars. So it means Aurora Borealis is northern crown. And it just looks like this nice little circlet of stars, about 7 stars, I think. And if we go on to the next slide, you can see So yeah, so it's in the west at the moment,
Is there any good pinpoints to help us try and find it?
yeah. So actually, if we go back to the previous slide just for a minute, let's see. So we've got Vega, and we were talking about Vega and Deneb earlier, and they're high in the sky in the west. So it's a little bit in the sort of southwest. And so a good place to start is Vega because it's one of the brightest stars. And then you go down to this constellation called Hercules, which has got a fairly distinct keystone, 4 stars, which look a bit like a keystone in an arch. And that's known as the Keystone Asterism. And then just beyond that, as we go down to the horizon, the same distance again, we come to Aurora Borealis. This little circle of star, but it is actually quite distinct when you look at the sky if you're in a dark location, or if you use a pair of binoculars. It's quite easy to.
Yeah, see, looking at stars, Kat, right? See, once you've found the circle, it's easy to pick out again and again. It's the first time you become a bit blind, blind with the dots, and then you get it and you go, oh, that's it, and you'll never miss it again. Yeah.
So if we look at the more detailed diagram in the next slide. So this is the constellation and the position of T Corona Borealis is on this is on the left there. So we know that it's
where the little
circle is. Yeah, that's T Corona, the location.
That's where it will be,
and it will be about as bright or maybe brighter than the bright stars on this diagram.
So that's like it's the top. So star on the left.
Yeah,
it's that little circle.
Yeah,
I've got it.
Yeah, that's it. Yeah. And it is actually possible to see it with the telescope. It's what we call 10th magnitude, which is pretty faint, but not indistinguishable to an experienced amateur astronomer.
But if that goes up to 1 magnitude, that'll outshine everything.
That will outshine all the rest. Yeah, that's right.
Can I ask what the difference is between a nova and a supernova? Because I've heard of a supernova, but not a nova.
Well, there are many there are different types of supernova, which makes it all
very complicated.
Very complicated. So the very biggest of stars, because they're very, very massive, will burn through all their material very quickly. And as they burn their material, they collapse. And when they collapse at their final stages, then they will explode in a supernova.
Yes.
And that's perhaps the simplest way.
They become so dense, so unstable that they put out all kinds of gamma rays and X-ray gamma, the most energetic things possible.
And there's also some which are double stars, a bit like these nova. Where you have stars which are more massive, and when the larger star runs out of fuel, then the star can't. A star is a balancing act. The balancing act between the gravity which is holding the star together and the pressure of the nuclear reactions in the core, which is like the thermal reactions and things which are pushing it out. So that's a balance. And in our sun, for example, that's carefully balanced so that it's just continues as it is. It's going to do that for millions more years.
I'm glad to hear that.
Yeah. As a star gets very old, it stops burning fuel, and depending on its size, if it's massive enough, it will start contracting. It will just contract and contract. And then if it contracts too much, there's nothing to, and the fusion stops, then it can just explode. And then that leaves us with supernova remnants and things, if you can see in the night sky. But an ordinary nova is, there's no death to either of the stars. It's just a pouring of material, which then becomes, if you like, ignited to show the flare. And if we look on the next slide, so this is a picture I took actually of the Aurora just a couple of weeks ago. I didn't intend to take this picture of this bit of Aurora, but the Aurora was actually happening in the north, and this is looking to the west from my location. I thought, it's a nice clear night. I'll take a picture of Aurora Borealis and see if this nova's gone off yet.
Well, I've just picked it out. I've just got Aurora Borealis, but it's actually it's right in the centre.
Yeah, it's right in the centre. Yeah. And I took this picture and found out this big pink red blotch of auroras right through the middle of the picture. If we advance in on the slides, we get a little pointer which will show you Aurora Borealis, and that's where the nova should go off, is precisely at that location. So it is quite a busy star field around Aurora Borealis. But once you, as Eric said, once you've seen it once, then you can always find it.
Yeah, no, it's a distinct curve of star.
Yeah,
pretty much the same brightness. Really.
That's good something. So something to keep an eye out for, and if it goes off, then it will be all over the media, everywhere when that happens. I think it'll be on the BBC. Yeah, and things. Most people have been waiting for this.
We've got a competition in a club where it's the first member that gets a photograph of it. We always run these little competitions to make things a little bit better.
So this is a light curve by amateur astronomers of the 1946 eruption of this recurrent nova, and on the big spike in the middle is where it actually went off, and down at the bottom where it's very, very faint. So we're in this sort of at the moment we're in this pre-eruption phase. And the light is sort of going up and down and up and down. There's quite a lot of oscillations. There are regular oscillations anyway, but it seems to be in this pre-eruption phase. So this is why some people think it's going to go off in the next couple of months.
I can see that now. I've got the scale. So on the left-hand side is the magnitude scale.
It's the brightness.
So the bigger number at the bottom is the dimmest.
Right.
Yeah.
And the low number at the top is the brightest, is that right?
That's
okay.
Right, yeah. And time is along the bottom, so we've got the year or month or date, some date, second, So it will go up very quickly, and then it will come down pretty quickly, and it will bounce around a little bit. But where it's down here around about 6th magnitude or so. That's still just about visible with the naked eye from Orkney Sky, good Orkney skies. But any fainter than 6th magnitude you won't see with the naked eye. But you still struggle to identify it, but you'd be able to see it with binoculars fairly easily.
A youngster with wider pupils might have a chance, but
people
of our age perhaps
not me.
Can't have a chance, but
And so that's one of the interesting events that we've got to look forward to.
Yeah, definitely in the diary. Well, it's not in the diary, it's in the hope. That's a possible, isn't it?
So how about comets? Are there any upcoming comets in our night sky? And also, can I just say we are getting questions through, and I'll put them to our speakers at the end as well.
Okay, good. What time we got? Right. Okay. So so I was just going to say the last supernova we had in our galaxy was in 1604, and we've not had one since. And the supernova, of course, is the brightest of stars, so we see that in the daytime if one goes off.
Are they dangerous to us?
Only if they're quite close by.
I'm not sure that's a good answer.
No, not very reassuring.
We will give off a lot of X-rays and stuff like that.
Yeah.
So we probably want one to be at
No.
the Alpha Centauri sort of scale from us, but anything further away is quite good. So moving on to comets, we've got an interesting comet potentially coming up in the next few months.
Brilliant.
It's currently behind the sun or heading behind the sun, so we can't actually observe it at the moment. So
How do you pronounce that, Callum? Oh, not sorry.
How would you pronounce it?
Very good.
So this is a comet called C2023 A3 Atlas, and it was also discovered by a Chinese observer. And unfortunately, I've not boned up on how to pronounce his name, but so I won't try and mispronounce it because I think that would be disrespect. So, but his name's here. So if we go on to the next slide, then mid-October it should start to become visible in in the sky, and this is the a sky map representation of where it will be. It's fairly low down, and this is, I think, on the 15th of October in the western
this is
sky.
Orkney again,
This is still Orkney, yeah. So it would be different if you're further south from. It would be a bit higher in the sky, and the sky will be darker as well. And that's where it will be at that time. It will actually become more visible over the following weeks in terms of its location on the sky. If we go on to the next slide, there's a little chart to show you where it will be moving. So it'll be moving from sort of the centre there to further north, further up and to the left. So it will be higher in the sky. Unfortunately, the comet will also be getting fainter at this time. So it's a bit of swings and roundabouts, really. So we'll see it at its brightest on something like 15th of October.
Yeah, so have we got any binoculars, telescopes?
Well, we think this could be a naked eye comet at this time. Fingers crossed.
It's been a few years since there's been one of those.
2020. It's been the last sort of naked eye comet. So fingers crossed, this one may be a naked eye one. It should certainly be easily visible with binoculars. And on the next slide, I've got a picture of this is this comet from 2020, Comet Neowise it was called, the lockdown comet, and it was a very bright comet. You could see it with the naked eye in a good sky. Nice white tail and a nice blue ion tail as well.
What's the time frame for it moving through the night sky? How long do people get to see it?
Well, it will be around it will be visible for weeks or months.
Okay.
But it will only be bright for a couple of weeks.
Okay.
Bright enough to be easily seen.
They're actually, when you do watch them, right, you watch them one night and they're in a position in the sky. Go and see them the next night and they will have moved. A noticeable, maybe like from the bottom of your thumbnail to the top of your thumbnail, but it's noticeable.
Yeah.
And if you can do astrophotography, you can do that.
So one of the challenges of astrophotography is because they move so quickly. They're moving so quickly that they actually become blurred compared to the stars. So if you were actually to blow up this picture and look at it in a bit more detail, you see that the head of the nucleus of the comet there is actually elongated because that's the movement of the comet against the stars, because all the stars are up and aligned in this picture process, and the experienced comet observers will track on the comet head or stack on the comet head, and then the stars would all be trailed.
Or if you use special software, you can remove the stars, get sharp clear comet, and then get your stars back in. So there's ways of doing it. Yeah.
Okay. Right, let's keep going because we've only got 10 minutes.
Yeah, so I want to get people's questions in.
Yes.
Our sun. So quickly, right, sun. So here's a couple of pictures of the sun. On the left is in what's called hydrogen alpha light. So that's the red light of hydrogen gas. And on the right, we've got a white light view of the sun. And I just wanted to put this in to show the sunspots. So we can see on white light that the sunspots are quite obvious, really. And in the H alpha view, you can't really, the sunspots are less distinct, really. But we can't see the prominences, which are these flares of gas coming off the sun.
Lots of activity on the sun just now. That's not fairly recent, I would say. Yeah,
this was just from a few weeks back. I read a report yesterday or the day before that the sun, people count the number of sunspots on the sun in white light on this picture on the right. And they've been doing that for centuries. And there's this record going back of the number of sunspots. And the current number of sunspots is the highest it's ever been in 23 years. So the sun is very active at the moment. And there's no particular reason why we can understand why sometimes the sun always goes through a cycle of 11 years from low activity to high activity. But what makes one high activity more than the last one is
so what does this high activity mean for us? What can we see? Well, those of us that don't have a solar telescope, what does it do to us?
Well, the effect of this is the impact on our geomagnetic fields and the aurora. So these materials which are being flung off these stars from these solar flares heads towards Earth,
So these are
interacts with
sources,
our upper atmosphere, and that shows us the aurora. So we've already had a couple of aurora this in August. If we go on the next slide, there's a couple of oh, sorry, there we go. Yeah. So yeah, we've had I think we've actually had 4 since
Yeah.
another one.
Had
Another one appears in the slides.
Yeah.
So yeah, increased solar activity, increased aurora. So going to the next slide, we'll see a couple of pictures. So this is a typical, if you like to call it, boring aurora from Orkney. If there's ever such a thing as a boring aurora. But you quite often get this sort of arc of green light or pierce white light to your eyes in the northern sky, and it just sort of sits there and looks like this for hours on end. And if you're patient and wait, and go to the next slide, you might see it burst into activity. And this is a few pictures from August. Of the rays that have appeared.
There was a huge one on May the 10th, I think it was, and I'm at 57.5 degrees latitude, and I think the auroral arc was about that. So I was looking into, the sort of origin of the thing, and it was like it's like rays were just emanating from all around it. It was spectacular, Callum.
Yeah. I actually missed it. I was in Glasgow at the time, and I didn't catch it.
Well, people
in Orkney did see it, and you had to be looking south to see it. It was not visible in north. And even when I was in Glasgow, I didn't see it because I was looking north. I was like polluted and buildings in the way in the south, but apparently there were lots of people saw all over Scotland and of course England, and
well, we're coming up to peak auroras. The equinoxes. I know they're notorious for allowing the sun's energy, the wind to.
That's right. There's because the Earth's the tilt of the Earth aligns with the plane of the sun. This means that more of the gases can get coupled into our magnetic field, which causes the aurora to be more prevalent around the equinoxes.
So what are the best times and locations to observe the Northern Lights then?
It's pretty much
predictable. You're just waiting for an alert and you go.
You need to look north. Basically, 99.9% of the rivers are in the north.
Okay.
East and west.
Look north, a clear, dark sky, good low horizon. I would say, so people look north, but they've got a hill in front of them or a woodland, and it takes off a lot of the available sky.
And these are digital SLR camera photographs, but you can do great stuff with smartphones. Night mode. On a smartphone will take terrific.
A smartphone on night mode is a great. The caveat is you've got to hold it steady. You'll never hold it in your hand for 2 or 3 second exposure. Rest on a fence post or side of a wall, your car roof. And just for that 3 of us, just breathe out as you're taking the picture, and you will achieve that, Carl.
I've seen great numbers. And if you want to find out when it's going to happen, then there's a couple of sites. So if we go on the next slide, you've got the Aurora Watch, and then on the next one, we've got the Aurora Watch website at Lancashire University, and they operate a magnetometer in Shetland, actually. And this is one of their plots of auroral activity. So basically, when it goes red, it's really, really active, and it's orangey. It's very active, and it's yellow.
I tend to think this is a wee bit after the fact.
It does tend to lag a little bit. It's particularly in these scales. If you look actually at the graph that it has, then that's a bit more accurate. But probably 2 places on the next slide, we've got a couple of other ways of finding out. So there's the Orkney Aurora Facebook group, which has got tremendous pictures, and as soon as there's anything to be seen on Orkney, then be pictures posted, so it's a great resource. And then on the left, there's what's called the Glendale app, and that's another really useful application. Install on your phone. It's it will have alerts, real-time alerts, and also real-time observations. So if you're registered, you can just click your on it and
okay, actually, this is at the top of the map there. What you see, the map at the bottom there, you'll see green ticks or red crosses or cloud shapes, and that's really useful to let you know where or near your location there are people currently observing the aurora, and is it worth getting in my car and going to my dark spot? And,
Very good.
Yeah.
So you've got the notification, you've got your phone or another camera device. What else might you need?
One coat.
Basically all you need is a one coat.
Yeah.
There's the next slide as well. I think is going to show us some binoculars as well that might help us. Or...
I think maybe we should just get into questions.
Questions, yeah, that's brilliant.
These are just
kind of touched on it already.
Kind of touched on.
Okay, so we've got some questions in from YouTube, so thank you for submitting. So the first one is, without the lines on star maps, I find it very hard to make out constellations. How can I approach working out and learning how to identify them? I guess we kind of talked about this earlier.
Yeah, it's you know, there's some of the names of the constellations, to be honest with you, they look absolutely nothing like what they're called. Right? Cygnus the Swan's not too bad, I get that one. But there are other ones that are just horrendous. So having someone that knows the sky to maybe with a laser pointer carefully used, so you don't,
of course, yeah,
especially not on an aircraft active area. But yeah, having someone with the knowledge to teach it is probably the best way. Yeah.
And the other thing to do is try and start with some easy constellations.
Oh yes,
as well.
The bright ones.
So and the bright ones, so White Ursa Major and Cygnus and
Orion when it comes up in the winter is always good. Yeah.
Taurus and Gemini are
they're all good.
Quite good constellations as well. And there's some asterisms around them. So like in Taurus, it's got this sort of V asterism, which is fairly obvious
with a red star
and a bright red star. So, and star colours is quite a useful way of finding your way around. There's lots of stars that have very particular colours, and if you can key in on those, then that helps you find your way around.
Another one is, who decides on the names for stars and constellations?
Well, it's the International Astronomical Union, which is the body which oversees all things astronomical.
There's a history of the stars are in different catalogues which have emerged over the centuries, and they've got different numbers or names and things. But yeah, the international
the IU has the final word now, and it was the IU that demoted Pluto from being a planet. So their word is final.
Absolutely.
Stephanie's given us a comment so about the name we couldn't pronounce, which is she says is the old transliteration into English of the name of the observatory in Beijing, China, where one of the first sightings of the comet was made in 1965, and now it would be Xingshan. I hope I pronounced that okay, which means Purple Mountain, in case anyone is interested. So it's a great insight.
That's excellent.
Brave.
And we've got one more question here, which is, how do you tell the difference between an arc of light and Steve? Which I'm not sure what that means.
See when Callum's referring to that picture he took of Aurora Borealis area with the red at the left, I actually thought that was Steve, but I'm not sure.
I'm not sure. So so a number of years ago, some observers noticed this unusual auroral-like streamer in the west of the sky, and it was very much detached from the aurora that was going on, so it was quite far in the west, as I remember, and it got called Steve because it was related to some cartoon character or something.
No, I think it's actually got that one of these acronyms.
No, it's a post acronym. So it got the name Steve after this character, and then they had to come up with some sudden thermal emission variable energy or something. I can't remember what's called. Anyway, so so to some extent it looks a bit like a ray, a bright ray in the western sky. I don't think I've ever seen one, and I've seen pictures of them. And quite often people say, "Is this a Steve?" And if it's near the auroral arc, then it's almost certainly not. If it's far away from the auroral arc, I'm not 100% sure. I'm really sure it's a
I'm
Steve.
going to have to look through some of my old ones because I definitely got a few of this inverted red comma kind of shape.
I mean, they look very bright in all the pictures I've seen. Very straight up from the western horizon, and very long as well.
Now the other name you said, I didn't even recognise the name.
Sorry, what's this one?
An arc of light and Steve, but there was a difference between those
Arc
two.
of light.
Yeah.
That is.
So yeah, so I mean, if there's an arc, well, as the aurora progresses, because we're quite high latitudes, as the aurora progresses, you'll get arcs of just as the normal auroral arcs, which will head over our heads, and you might still get the aurora superauroral arc. Yeah. So that green band I showed earlier, that can just head overhead, and then but that's just a natural expansion of the aurora overhead. And that is, I think it's different in. See, I think that that red patch I captured is just part of the general auroral glow, which is expanded overhead.
A different height from the green one. Yes.
Exactly. Yeah. So it's gone overhead, basically. Yeah. So when you see the auroras with the green band and then the red above, I think that's just a perspective effect that's going over our heads. So
I didn't hear that. It's too much.
It's too much.
Yes. Well, thank you for submitting all your questions today. They were brilliant. And I hope you enjoyed our discussion. And thank you to our lovely speakers. Yeah, the Orkney Science Festival continues to run until Wednesday the 11th, with plenty of events for you to get involved in. Another opportunity to see myself speaker hosting is at the Dam Builders. You can see Callum's research, I guess, at the town hall with the Comet installation in coordination with Linda Laird, which is great. It's a great thing to visit. Please do. And Eric, do you have any other events that you would like to advertise?
Oh, you've got me right. I've got speaker hosting for a few. I've gone blank. I've gone absolutely blank, and I've got a few to do. But yeah, you'll see if you're here in Orkney, you will definitely see me, bump into me, no problem.
Brilliant.
And if you head to the cathedral and see the RS code,
of course, yes, with the astronomers.
You're on duty on that on Sunday. I'm just after you, actually.
So if you've got any astronomy questions, want to come along to the
head to the right hand side.
Go there on Sunday afternoon from 3.
3 to 5 I'm on, and you're on the 2 hours.
I'm on the 2 hours before.
It's a brilliant thing that combines crafting and astronomy, so it's a really great discussion point. So if you've enjoyed the festival as well, don't forget to like us on Facebook, Twitter and Instagram, and follow our YouTube channel too. Leave your comments as well down below. And we also have a TikTok now, so please follow us on there. You can keep up to date with all the things that go on throughout the festival year by following along on these different social media platforms. Out with the festival too. Thank you very much. Goodbye.